All right, so let's write this down. And I'm going to write down Z1. I'm getting a little better at this. And I'm going to put the modulus down first. So it's root 2 squared plus root 2 squared. That's going to be 2 plus 2, which is 4. The square root of that is 2. And the angle, if I visualize that, it's 45 degrees. I'll write that down, CIS. Z2 is a little more complicated, but I still want to visualize it. And I got to square those things. I want to get the modulus first. That's 25 quarters. And the other guy's going to be 25 times 3, which is 75 quarters. And that's going to be 100 quarters, which is 25. And the square root of 25 is 5. CIS. Let's get my eraser out. Baby right there on the side. Get rid of it. I'm going to figure out the angle now. And it's a little more complicated, but I recognize those numbers certainly. And yeah, it's a nice, easy reference triangle, right? So let's put this down over here. Again, I'm trying to visualize it. 5 over 2. And this was 5 root 3 over 2. And this was 5. And I clearly recognize that as a 60-degree triangle. All right? If you want to use radians, you can. The radian measure for that would be pi over 3. But I'm going to use 60 degrees because it's easier for me to do. Get my eraser out. I'm done visualizing. And I want to do the multiplications. And I'm going to do Z1 times Z2. Once it's in that polar form, it's really easy for me to do. 2 times 5 is 10. CIS. 60 and 45 is 105 degrees. Let me do Z2 divided by Z1. A little more complicated. Z2 is 5. CIS. 60 degrees. And 2 is Z1. CIS. 45 degrees. What's that going to equal to? 5 divided by 2, CIS, 60 minus 45, which is 15 degrees. All right? I'm going to put boxes on these answers over here indicating that's my answer. Yep, I'm using degrees. I don't know what they're using, but I do see some work down over here. I do see they use the radian measure. But let's take a look. And I gotta check it. So I'm looking at their answer, get my answer, and I do see some commonalities between it. I see 10 here, and I see 5 halves over here. But I'm going to check the numbers now. All right, so 105. Whoops. I did it again. 105 degrees times pi over 180 degrees. They're claiming that's 7 pi over 12. Well, let's see if that's true. And I'm looking at it, and yeah, I'm going to divide top by 15. Let me go for that. All right, 15 goes into 105 7 times. 7 times 5 is 35. 7 and 3 is 10. Yep, 7. And I'm going to divide 15 into 180. Once, 15, 3, 0, 12. Yeah, 7 pi over 12. That worked out. Let's do the other one, 15 degrees. A little bit simpler, isn't it? 15 times pi over 180 degrees. You can see why radians sometimes can be quite difficult, all the converting back and forth. And degrees are like a lot easier, a large number of divisors, and they're really kind of easy to deal with. But look at this, and yeah, that looks like pi over 12. And again, 12 times 15 is 150 and 30. We just did that, by the way. All right? Things are working out beautifully. Thank you.